Alright folks, I've been thinking a lot and looking at the discussions in the edX forum. I thought that I'd make a nice snappy video on how to approach problem set 2, question 3. So essentially, they're talking about this thing called bisection search, right? Bisection search, which is really nothing but essentially searching by cutting out one half and kind of looking in the other. So let me demonstrate, okay? So essentially, we are given a balance, right? We are given a balance, and say this balance is equal to something like, I don't know, $6,000, right? And we are given an annual interest rate. Remember folks, these things are in camel case. So let's say that this is, I don't know, 0.18. Okay, so what we have to do first in order to use bisection search is that we need to establish an idea of what is the maximum that we can pay and what is the minimum we can pay, right? So let's take a line, right? Let's imagine this is a line, and let's look at the minimum. This is the minimum, right? This is the minimum, yay, and this is the maximum. This is the maximum, and somewhere in the middle there's this teensy little guy, and that's the mid, right? That is the mid. So essentially what bisection does is establish the minimum amount that you can pay. So what would be the minimum amount? The minimum amount would be, so the minimum amount, so let's say what we're going to pay, and let's call it, I don't know, payment, right? Payment. So this would be somewhere between the minimum and the maximum, right? So let's think about what the minimum could be. If we paid absolutely no interest whatsoever, say we met a really nice bank manager and he said, well, you know, you don't have to pay any interest. So the minimum we could get away with would be $6,000 over 12 months without any interest. So it would be simply it would be the balance by 12, right? That would be the minimum amount. Now the good folk at MIT have already done the calculations. They told you what the minimum is, they told you what the maximum is, and yeah, and you can make these more efficient if you want, but I don't really know why you would want to, since that would increase your workload. So and the maximum would be, say you had, you know, I don't know, the maximum compounded interest over your, I mean, you have to pay say the maximum possible interest for every month. So that would be, I don't know, your balance times 1 plus annual interest rate over, okay folks, this is just this and this are the same thing, I just kind of like using shorthand, over 12 to the power of 12. I don't exactly remember on the top of my head what exactly that calculation was, but it was some big fancy number, and what you need to know is that you don't need to worry about it, okay? So let's think about it like this, right? So we know the minimum, we know the maximum, and what we're going to do is essentially evaluate the mid, right? We are continuously going to I don't know, take a look at the middle section and see if that is enough for us to pay our way through the year, and that has to be the minimum amount that we pay per month, and have no balance remaining at the end of the year. Okay, so what I did is essentially I did the evaluating part, whether it was enough, it was too much, or or too little in a simple function called evaluate payment, right? So I just evaluate payment. I can't write all this, and I just kind of plugged in. These values, right? I just plugged in these values over here. That's all I did. And so what my wonderful code did, you see, is it gave me what would be the remaining balance if I paid that amount every single month, right? So this is your code, and what you need to do is that this part of your code, the function, already evaluates, and you've already done this, I think in problem set 2, part 1. So this is not going to be a big problem for you. But let's evaluate the evaluation of our payment, okay? So if, say, evaluate pay returns more than 0, yeah, so evaluate, let's just say eval pay of payment is greater than 0.00, and you can use this in Python. You don't have to specify an epsilon. You can use this in Python, and it's perfectly fine. If it's greater than, so essentially you still have money remaining. That means that you have to pay more, right? Because your amount was not enough. So you have to pay from the mid, between the mid and max, right? So you've searched, you've evaluated, and you realize that, well, you know, it's not enough, so we need to search somewhere along these lines. So your mid becomes the new min, and your max remains the max. And you bisect this part and say it was still not enough, this part, and say it was still not enough, this part. Or say you evaluated and you evaluated and you found out that it was too little, right? So your mid would become the new maximum, and essentially you would take the mid between the min and the new maximum, which was the previous mid, and just cut it in half, and you cut it in half until you found the amount that you were looking for.